The low-rise buildings considered include apartment houses, office buildings, warehouses, schools, and institutional buildings that are not very tall with respect to their least lateral dimensions. Types of steel frames used for buildings: bearing wall construction, skeleton construction, long span construction, and combination steel and concrete framing. Bearing wall construction is the most common type of single-story light commercial construction. The ends of beam or joist light trusses are supported by the walls that transfer the loads to the foundation. The old practice was to rapidly thicken load-bearing walls as buildings became taller. For instance, the wall on the top floor of a building might be 1 or 2 bricks thick, while the lower walls might be increased by 1 brick thickness for each story as we come down the building. As a result, this type of construction was usually thought to have an upper economical limit of about 2 or 3 stories, although some load-bearing buildings were much higher. The tallest load-bearing building built in the United States in the 19th century was the 17-story Monadnock Building in Chicago. This building, completed in 1891, had 72-inch thick walls on its first floor. Bearing wall construction is not very resistant to seismic loadings and has an erection disadvantage for buildings of more than 1 story. For such cases, it is necessary to place the steel floor beams and trusses floor by floor as the masons complete their work below, thus requiring alterations of the masons and iron workers. Bearing plates usually are necessary under the ends of the beams or light trusses that are supported by the masonry walls because of the relatively low bearing strength of the masonry. Although, theoretically, the beam flanges may on many occasions provide sufficient bearing without bearing plates. Plates are almost always used, particularly where the members are so large and heavy that they must be set by a steel erector. The plates usually are shipped loose and set in the walls by the masons. Setting them in their correct positions and at a correct elevation is a critical part of the construction. Should they not be properly set, there will be some delay in correcting their positions. If a steel erector is used, he or she probably will have to make an extra trip to the job. When the ends of a beam are enclosed in a masonry wall, some type of wall anchor is desirable to prevent the beam from moving longitudinally with respect to the wall. The usual anchor consists of bent steel bars passing through beam webs, these so-called government anchors shown in Figure 19.1a. Occasionally, clip angles attached to the web are used instead of government anchors. These are shown in Figure 19.1b. Should longitudinal loads of considerable magnitude be anticipated, regular vertical anchor bolts may be used at the beam ends. For small commercial and industrial buildings, bearing wall construction is quite economical when the clear spans are not greater than roughly 35 or 40 feet. If the clear spans are much greater, it becomes necessary to thicken the wall and use pilasters to ensure stability. For these cases, it may often be more economical to use intermediate columns if permissible. Skeleton construction. The loads are transmitted to the foundations by a framework of steel beams and columns. The floor slabs, partitions, exterior walls, and so on, all are supported by the frame. This type of framing, which can be erected to tremendous heights, often is referred to as beam and column construction. In beam and column construction, the frame usually consists of columns spaced 20, 25, or 30 feet apart, with beams and girders framed into them from both directions at each floor level. One very common method of arranging the members is shown in Figure 19.2. The more heavily loaded girders are placed in the short direction between the columns, while the comparatively lighter loaded beams are framed between the girders in the long direction. It is common practice to orient columns in a way that will minimize eccentric loading. Many engineers will orient columns so that the girders will frame into the web and beams will frame into the flats, as shown for the interior bay in Figure 19.2. With various types of floor construction, other arrangement of beams and girders may be used. For skeleton framing, the walls can be supported by the steel frame and generally are referred to as non-bearing or curtain walls. The beams supporting the exterior walls are called spandrel beams. These beams illustrated in Figure 19.3 can be placed so that they will serve as the lintels for the windows or other openings. Long-span steel structures. When it becomes necessary to use very large spans between columns, such as for gymnasiums, auditoriums, theaters, hangars, or hotel ballrooms, the usual skeleton construction may not be sufficient. Should the ordinary roll W section be insufficient, it may be necessary to use cover-plated beams, built-up I-shaped girders, box girders, large trusses, arches, rigid frames, and the like. When depth is limited, cover-plated beams, plate girders, or box girders may be called upon to do the job. Should depth not be so critical, trusses may be satisfactory. For very large span arches and rigid frames often are used. These various types of structures are referred to as long span structures. Figure 19.4 show a few of these types of structures. Combination steel and concrete framing. A large percentage of the buildings erected today make use of a combination of reinforced concrete and structural steel. When reinforced concrete columns are used in very tall buildings, they are rather large on the lower floors and take up considerable space. Steel column shapes surrounded by and banded to reinforced concrete may be used and are referred to as encased or composite columns. Composite columns consisting of HSS members filled with concrete, called filled composite columns, may also be used. Common types of floor construction. Concrete floor slabs of one type or another are used almost universally for steel frame buildings. They are strong and have excellent fire ratings and good acoustic ratings. On the other hand, appreciable time and expense are required to provide the formwork necessary for most slabs. Concrete floors are heavy. They must include some types of reinforcing bars or mesh, and there may be a problem involved in making them watertight. The following are some types of the concrete floors used for today steel frame buildings. Concrete slab supported with open web steel joists, one-way and two-way reinforced concrete slabs supported on steel beams, concrete slabs and steel beam composite floors, concrete pan floors, steel decking floors, flat slab floors, precast concrete slab floors. Among the several factors to be considered in selecting the type of floor system to be used for a particular building are loads to be supported, fire rating desired, sound and heat transmission, dead weight of floor, ceiling situation below, to be flat or to have beam exposed, facility of floor for locating conduits, pipes, wiring, and so on, appearance, maintenance required, time required to construct, and depth available for floor. Concrete slabs on open web steel joists. Perhaps the most common type of floor slab in use for small steel frame buildings is the slab supported by open web steel joists. The joists are small parallel cord trusses whose members usually are made from bars, hence the common name bar joist, or small angles or other rolled shapes. Steel forms or decks are usually attached to the joist by welding or self-drilling or self-tapping screws. Then concrete slabs are poured on top. This is one of the lightest types of concrete floors and also one of the most economical. A sketch of an open web joist floor is shown in Figure 19.5. Open web joists must be braced laterally to prevent them from twisting or buckling and to keep the floors from becoming too springy. Lateral support is provided by bridging, which consists of continuous horizontal rods fastened to the top and bottom chords of the joist or of diagonal cross bracing. Bridging is desirably used at spaces not exceeding 7 feet on centers. One-way slabs. A very large number of concrete floor slabs in old office and industrial buildings consisted of one-way slabs about 4 inches thick, supported by steel beams 6 to 8 feet on centers. These floors were often referred to as concrete arch floors because at one time brick or tile floors were constructed in approximately the same shape, that is, in the shape of arches with flat tops. One-way slabs have an advantage when it comes to formwork because the forms can be supported entirely by the steel beams with no vertical shoring needed. They have a disadvantage in that they are much heavier than most of the newer lightweight floor systems. The result is that they are not used as often as formerly for lightly loaded floors. Should, however, a rigid floor, a floor to support heavy loads, or a durable floor be needed, the one-way slab may be the appropriate selection. Two-way concrete slabs is used when the slabs are square or nearly so, with supporting beams under all four edges. The main reinforcing runs in both directions. Other characteristics are similar to those of the one-way slab. Composite floors have steel beams or rolled sections, cover-plated beams or built-up members, banded together with concrete slabs in such a manner that the two act as a unit in resisting the total loads that the beam sections would otherwise have to resist alone. The steel beams can be smaller when composite floors are used because the slabs act as part of the beams. A particular advantage of composite floors is that they utilize concrete's high compressive strength by keeping all or nearly all of the concrete in compression, and at the same time stress a larger percentage of the steel in tension than is normally the case with steel frame structures. The result is less steel tonnage in the structure. A further advantage of composite floors is an appreciable reduction in total floor thickness, which is particularly important in taller buildings. A particular advantage of steel decking floors is that the decking immediately forms a working platform. The corrugated steel floor decks are quite strong due to the strength of the decking. The concrete does not have to be particularly strong, which permits the use of lightweight concrete, often as thin as 2 or 2.5 in depending on the space of the supporting beams or joists. The cells in the decking are convenient for conduits, pipes, and wiring. The steel usually is galvanized, and if exposed underneath, it can be left as it comes from the manufacturer or painted as desired. Should fire resistance be necessary, a suspended ceiling with metal lath and plaster may be used. Flat slab floors. Formerly, flat slab floors were limited to reinforced concrete buildings, but today it is possible to use them in steel frame buildings. A flat slab is reinforced in 2 or more directions and transfers its loads to the supporting columns without the use of beams and girders protruding below. The supporting concrete beams and girders are made so wide that they are the same depth as the slab. Flat slabs are of great value when the panels are approximately square, when more headroom is desired than is provided with the normal beam and girder floors. More headroom when heavy loads are anticipated and when we want to place the windows as near to the tops of the walls as possible. Another advantage is the flat ceiling produced for the floor below. Precast concrete floors. Precast concrete sections are more commonly associated with roofs than they are with floor slabs, but their use for floors is increasing. They are quickly erected and reduce the need for formwork. Lightweight aggregates are often used in the concrete, making the sections light and easy to handle. Some of the aggregates used make the slabs malleable and easily cut and fitted on the job. Floor slabs with their fairly heavy loads, the aggregates should be a quality that will not greatly reduce the strength of the resulting concrete. Some of the common types available are listed here, and a cross-section of each type mentioned is presented in Figure 19.2 due to slight variations in the upper surfaces of precast sections, it is usually is necessary to use a mortar topping of 1 to 2 inch before asphalt tile or other floor coverings can be installed. First is the precast concrete planks are roughly 2 to 3 inch thick and 12 to 24 inch wide and are placed on joists up to 5 or 6 feet on center. They usually have tongue and groove edges. Second is the hollow cord slabs are sections roughly 6 to 8 inch deep and 12 to 18 inch wide and have hollow, perhaps circular, core formed in a longitudinal direction, thus reducing their weights by approximately 50% as compared with solid slabs of the same dimensions. These sections, which can be used for spans of roughly 10 to 25 feet, may be pre-stressed. Third is the prefabricated concrete block systems are slab made by tying together precast concrete blocks with steel rods may also be pre-stressed. These seldom used floors vary from 4 to 8 inch depth and can be used for spans of roughly 8 to 32 feet. The last one is the channel slabs are used for spans of approximately 8 to 24 feet. Rough dimensions of these slabs are given in figure 19.12. Types of roof construction commonly used for steel frame buildings include concrete slabs on open web joists, steel roof deck, and various types of precast concrete slabs. For industrial buildings, the roof system in predominant use today involves the use of a cold rolled steel deck. In addition, the other types mentioned in the preceding sections on floor types are occasionally used, but they usually are unable to compete economically. Among the factors to be considered in selecting the specific types of roof construction are strength, weight, span, insulation, acoustics, appearance below, and type of roof covering to be used. Steel decking with similar thin slabs of lightweight and insulating concrete placed on top make very good economical roof systems. A competitive variation consists of steel decking with rigid insulation board placed on top, followed by the regular roofing material. The other concrete slab types are hard-pressed to compete economically with these types. For lightly loaded roofs, other types of poured concrete decks required much more labor. Exterior walls. The purpose of exterior walls are to provide resistance to atmospheric conditions, including insulation against heat and cold, satisfactory sound absorption and light refraction characteristics, sufficient strength and acceptable fire ratings. They also should look good and yet be reasonably economical. For many years, exterior walls are constructed of some type of masonry, glass, or corrugated sheeting. Recently, however, the number of satisfactory materials available for exterior walls has increased tremendously. Precast concrete panels, insulated metal sheeting, and many other prefabricated units are commonly used today. Of increasing popularity are the light prefabricated sandwich panels consisting of 3 layers. The exterior surface is made from aluminum, stainless steel, ceramics, plastics, and other materials. The center of the panel consists of some type of insulating material, such as fiberglass or fiberboard, while the interior surface is made from metal, plaster, masonry, or some other attractive material. Interior partition. The purpose is to divide the inside space of a building into rooms. Partitions are selected for appearance, fire rating, weight, and acoustical properties. Partitions may be load-bearing or non-load-bearing. When we say bearing partitions, it supports the gravity loads in addition to their own weights and are thus permanently fixed in position. They can be constructed from wood or steel studs or from masonry units and faced with plywood, plaster, wallboard, or other material. While the non-bearing partitions do not apply any loads in addition to their own weights and thus may be fixed or movable. Fireproofing of structural steel. Although structural steel members are incombustible, their strength is tremendously reduced at temperatures normally reached in fires when the other materials of a building burn. Many disastrous fires have occurred in empty buildings where the only fuel was the building themselves. Steel is an excellent heat conductor and fireproof steel members may transmit enough heat from one burning compartment of a building to ignite materials with which they are in contact in adjoining sections of the building. The fire resistance of structural steel members can be greatly increased by coating them with fire protective covers such as concrete, gypsum, mineral fiber sprays, special paints, and other materials. The thickness and kind of fireproofing used depends on the type of structure, the degree of fire hazard, and economics. The cost of fireproofing structural steel buildings is high and hurts steel in its economic competition with other materials. As a result, a great deal of research is being conducted by the steel industry on imaginative new fireproofing methods. Among these ideas is the coating of steel members with expansive and insulative paints. When heated to certain temperatures, these paints will char, form, and expand, forming an insulative shield around the members. These swelling or extravagant paints are very expensive. Other techniques involve the isolation of some steel members outside of the building where they will not be subject to damaging fire exposure, and the circulation of liquid coolants inside box or tube-shaped members in the building. It is probable that major advances will be made with these and other fireproofing methods in the near future.